Mr. Jim Berryman, the liaison librarian from the Brownless Biomedical Library. Jim is an expert on everything library skills and also does research on art history. So please feel free to put any questions you have in the chat box and I'll read them out for Jim to answer. Jim?
Thank you very much, Eddie. Look, welcome and thank you for joining us. We have scheduled an hour. I will go through the process of building a search strategy based on a research question or topic. I'll talk a little bit about the planning process of literature searching. I have some slides, but I won't refer to the slides too much. I want to use this as an opportunity to build a search live. I want to build a search on an Ovid database, Medline Ovid. I'll run that search on PsycInfo. I'll talk about the functionality of these particular databases. I want to also run the same search on a different database, maybe Web of Science or Sonal, see how we go for time, just to demonstrate some differences in these database platforms. Look, before we start, are there any questions, comments? There will be opportunity to cover the questions. That's good. Look, I'll start with my slides and I'll share my screen. Just bear with me. You can see the slide okay? Good. It's there? Great. This is a screenshot of the Prisma flow diagram. Even if we aren't working on a formal systematic review or meta-analysis, I still like to use the flow diagram to demonstrate the process of literature searching and how it fits. The first step, the first box up there says records identified through database searching, and that's what we will cover today. When we start a research project, it doesn't have to be a formal scoping review or systematic review. It can be any type of research project. We start with some kind of structured search of the literature. That's what we'll look at now. Records identified through database searching. When I refer to databases, resources such as Web of Science, Scopus, Medline, PsycInfo, etc. Okay, bear with me. That's the research topic that I'll look at this afternoon. This is a topic from a few years ago. I was working on someone with about 4 years ago now. Association between eating disorders and autistic traits in adolescents. So that's the search we're going to look at now. Look, when we start any type of literature search, I urge you to consider the topic or the question and to identify the key themes or concepts, because ultimately this is the basis of our literature search. I've identified 3 themes here: eating disorders, autistic traits, and our population adolescents. I'm hoping the association will be implied when we run the search. Searching is, as I like to say, it's a process of language and logic. That's all it is. It's a language game. Think about the key concepts or themes and identify related phrases, synonyms, if you like, for these components. This is not exhaustive by any means. But, I just brainstormed these. I've come up with some related terms that I can string together for this component of my search. When we run this search live shortly on Medline Ovid, I will refer you to the mesh thesaurus. Medical subject headings, we'll explain this later when I run this live. The mesh thesaurus, the medical subject heading thesaurus, on Medline works as a regular language tool. We can search for some themes on the Mesh thesaurus, check the scope notes, to come up with some related phrases. So if you get stuck trying to think of some terms, we can use resources such as Mesh. These are some terms that I brainstormed. Again, it's not exhaustive, but these are the themes. Eating disorders, feeding and eating disorders, eating disturbance, anorexia. The middle column, which I hope you can see, I should have put this in darker font, sorry, relates to the autism theme of the search. The last theme, dealing with the population, I couldn't think of anything else to really add. Adolescent, teenager, young adult. I suppose I'm looking at an age in this case between, say, I don't know, 13 to maybe 25. So these are the three themes with some related terminology. While I'm planning a search, at this stage I like to think about, again, truncation, word truncation. These databases support word truncation. Google Scholar, regular Google doesn't do this. So we can truncate some word stems to pick up some variants. It's an efficient way of searching. And this will have a bearing on your results. Here are just some examples that I chose. I mean, eating disorder, for example, to put the asterisk, the star will pick up disorders. Adolescence, an interesting case. So after the N in that word stem, I could pick up adolescent, adolescence, adolescence, etc. Asperger's also interesting in this case. Think of Alzheimer's disease, Parkinson's disease, Asperger's syndrome. Truncate. If we didn't, if we just use the apostrophe, the S, we won't get those papers that are just referring to Asperger syndrome. These are little hints that you'll pick up as you become more experienced with searching. This will make more sense when we run a live search shortly. Look, this is the test search. This is the search that I want to run live. This will be clearer when I build this search. It doesn't, look, it's not as complicated as this search string appears. One of the benefits of using a resource such as Medline or Web of Science is the ability to break the search up into themes. When we run a search, we're essentially using two operators, the OR to group together related concepts and the AND to combine these search sets. Eating disorder and autism and teenagers. After you run your search, these are some points to consider. With any type of systematic or structured searching, it's again a process of experimentation, hit and miss, trial and error. So don't stress too much about it to begin with. You know, we experiment with the search terms, we group them together, we run the searches, we get results. The process could take a while, but after, you know, a few goes, you look at the results, they look good. That's your search strategy. Even if you aren't doing, again, a formal scoping review or systematic review, I still think it's good to keep some kind of record of the process. Right. What I'll quickly do now, in fact, I might disable the video just to save the bandwidth. What I want now is run our search. Now, this is the Population Health and Global Health Guide. I hope you've seen this already. Eddie will make this available to us after the session. This is the resource that I've built for the discipline area. But look, if you haven't encountered this already, I'll draw it to your attention now. There is a sub-guide built into this, the Research Literature Searching Guide. There again are some principles here which you can look at later. The databases. This is not an exhaustive list of the databases, but it contains, I think, key databases that we can use in our discipline area. There's Medline Ovid, which I'll search shortly. Some other databases here. Incidentally, there are some slides here as well, which you can look at later. Examples of searches. Scopus, Sonal, Web of Science. But what I want to do is build a search. Now, to access these databases, click there. You'll be prompted to enter your username and password. These are licensed databases and they aren't freely available. I've opened Medline Ovid. Again, depending on your topic, if it's looking at a fairly traditional health or medical area, I always start with Medline. Point number one, the default is set at basic search. For structured or systematic searching, select the advanced search. Basic search discourages search building. Now, before I run my search and talk about Medline, the advanced search, I mentioned the mesh thesaurus. Map term to subject heading. This box is unticked. When I'm planning a search, I like to consult the mesh thesaurus. Advanced search, tick that box. Eating disorders. When I run search now, it isn't running the search as such. It's directed me to the mesh thesaurus, the medical subject heading thesaurus. Mesh refers to the standard subject headings that Medline and PubMed uses to index the records on the database. The preferred mesh term for eating disorders is feeding and eating disorders, but our search will still capture this heading because we will use eating disorders. Mesh is hierarchically arranged. So what I like to do when I'm building a search, I'll click on that descriptor. Eating disorders, or feeding and eating disorders, as PubMed and Medline are referring to them, sit under the mental disorders heading, which sits under the psychiatry and psychology heading. General headings to specific. This is what I'm looking for here. So under the feeding and eating disorders, when I'm planning a search, I like to consult Mesh, and it's a process then, I think, of just copy and pasting relevant terms into your search string. You don't need to use them all, just those that are relevant. When I'm planning a search using Mesh, I also like to look at the scope note. It's a thesaurus. When we click on the scope note, we get a definition of the concept. And look, some additional related terms that could be helpful when we are planning our search. I can incorporate some of these into my search string. Eating disorder or appetite disorder, for example. You don't have to use them all, just those that you think are relevant for your topic. So when we select the advanced search, and it always falls back to the basic search on the Ovid databases, be sure to select advanced. That box is usually unticked. So you can look at the thesaurus to get some ideas. I've already built the search string. I like to work from a Word document and copy and paste my searches into the database. I like to plan when I'm using a Word document. Here's my search string with the ors between these related terms and the asterisk to pick up some plurals. They're the searches I entered into the database. These terms appear automatically. The database adds these. Searching is pedantic. The databases are pedantic tools. The thing to remember is this: if you select advanced search and you do not specify a particular field, title or abstract or whatever, the database, the Ovid databases, will automatically run what's called an MP or a multi-purpose search. It's important to remember that we aren't searching the full text paper. We are searching the record, the title, the abstract, the keywords, the subject headings, etc. So we have to think, how would a study be described? The MP, I think, is a good search option because it's searching those text-heavy fields, title, abstract, subject heading, etc. The search history is up here. Right. My second search. Now, autism, autistic, truncate. Search. There's the search history. It's added to the earlier search. Remember, the third theme of my search was the population, the adolescent population. Right, so I will now add adolescent or teenager or young adult search. I stress again the importance of selecting the advanced search because what I'm about to do doesn't work with the basic search. What I'm doing now is combining these search sets, building a structured search. Search one. The operators are down here, and or. They're grayed out now, but when I click on my second search, it activates the connector. Search one, and search two, and search three. And that's a good start. I get 219 papers on Medline. So search 4 has one or more of these terms from these groups. Results are displayed down here. Title, abstract, autistic-like, adolescence, eating disorder. Again, this is my first search, still very much a trial or piloting stage. I usually like to look at the results to get a sense of accuracy. Some of these look promising, actually. Yeah. You can go back and refine a search, and I'll do that shortly. Look, incidentally, with the Ovid databases and these other databases, sometimes there's full text freely available, a PDF icon. If not, click on Find It at UniMelb to link out to the full text. There's instructions on the guide. which I referred earlier. We won't waste too much time now looking through these results, but I'll quickly go back to my search. What I would recommend doing, for example, I could add some additional terms here. The databases, the Ovid databases, especially have the option to set an additional limit. So for example, I'm looking at literature published, say, in the last, let's say, I don't know, 10 years. There are all sorts of limiting options here: study types, RCTs, etc., systematic reviews, language. By the way, I should say this, the records on the databases are all in English, but some of the full text papers themselves could be in different languages. On Ovid, square brackets around a title indicates the paper is not English language. It could be in Korean, Chinese, Bulgarian, but the references are in English. So you can limit to English language only if you like. What I will do now is apply that limit, give it a search. So I've set a 10-year date range for my topic using the additional limits and, you know, a smaller number of results. The more ands we add to a search, the fewer results. How many results is a good number of results? This totally depends on your topic. Look, if we are working on a scoping review of some type, a more comprehensive review of the literature, I think anything under, dare I say it, you know, 500, maybe even 700 is a good number these days. These databases are enormous. There are almost 30 million records on Medline, PubMed now. I prefer to run a search and end up with several hundred, or dare I say a few thousand results, because there's always potential to add qualifying terms to narrow the results. We can set a date range, we can add some other concepts. There's nothing more frustrating, I think, than running a search and ending up with 5 or so results. I prefer to run a search that's pretty sensitive and then refine as required. That said, it totally depends on your topic. Some topics, of course, are better covered than other topics. Before I stop and ask for questions, I just want to quickly demonstrate something else. We're on, and this is confusing, we're on Medline Ovid. The database is Medline. Ovid refers to the publisher or the platform. Ovid is not a database as such, but it's a platform through which we can access databases. We're running Medline Ovid. The content on Medline is pretty much the same as the freely available PubMed. I would usually recommend using Medline instead of PubMed while we're at the University of Melbourne, because we run other databases through Ovid, such as PsycInfo and Embase and the Cochrane products. So for example, I'm searching this topic. I've built a search on Medline. What I want to do now is run this topic on PsycInfo, which we also run through Ovid. There's an easy way to do this. Change. Change. This is a list, a menu of the Ovid databases we have access to at the university. Most of these you don't need to worry about. Most of these I haven't even looked at myself. But look, down here, there's PsycInfo, APA PsycInfo. Given the nature of this topic, I think it's worthwhile running the search on PsycInfo as well. Run search. We're still on Ovid, but look, we're now on PsycInfo. 204 results. There's more on PsycInfo, and I'm not surprised given the topic that we're looking at. Again, there's the search that we built on Medline. The title, abstract, subject headings are still there. That's okay. Results are down here. Now, this is also important. When we start searching multiple databases, Medline, PsycInfo, Web of Science, you must expect to encounter quite a lot of overlap between the databases. There's a number of ways to manage this. What I prefer to do is select all and export. For example, I could now export these to Endnote and manage the duplicates in an Endnote library. So I'd run my search on Medline, export, PsycInfo, export to Endnote, click on references in Endnote, find duplicates and remove duplicate records. If you're good with Excel, I was working with a researcher yesterday, she prefers just to use Excel. You can do exactly the same there. Export and manage the duplicates. I like Ovid databases because it's really easy to get the data out of them. Now, this is also important, especially for those of us who are working with Endnote or are working on a review. Be sure to select the citation abstract if you are exporting the results. The default is set at citation. You will only then just get the basic citation. I think it's important and necessary for scoping reviews and systematic reviews to select the abstract as well. So be sure to select the abstract. Then it's a case of export and a data file will download. Theoretically, with the Ovid databases, you can search multiple databases concurrently. I find that really frustrating. I think the best practice is to search one database at a time, export results, record the number of results. And again, with Ovid, it's nice and easy. Look at this change. I'll go back to Medline Ovid. Here we go. Run search. Now, most of the material that we will find on these databases are published journal articles, especially with Medline. PsycInfo is unique. It will have some book chapters, some edited books, and maybe some theses and dissertations as well, mostly journal literature. Embase, which I won't open now, also includes conference abstracts. I find that they're annoying. I don't tend to like conference abstracts in my search results. So if you're searching Embase, you can remove the conference abstracts by just selecting articles or articles in press. And on the guide that I showed us to begin with, the instructions are there. There's Embase there, by the way. Okay, what I will do now. Questions, comments before I continue. All good?
Jim?
Yep.
All good. So I'd like to ask, if you're running a search for an assignment or a research project, and you want to look at those studies that are in press, such as topics on COVID-19, a lot of the topics or a lot of the papers will not have been published. Where would you think is the best place to go?
Look, certainly for most of our assessment tasks, I would probably recommend not using a lot of the pre-pub archives. Maybe for some topics, if we're doing a significant research project, say on COVID, there are archives available. I can refer you to them later, but I worry about some of these for coursework students because a lot of these pre-pubs don't necessarily end up published. Or when they are published under different names. I've encountered that already. Look, Web of Science, which I'm going to demonstrate shortly, And Medline Ovid will publish what I call pre-pubs or ahead of, okay. They have been published, but they haven't been assigned to volumes or issues yet. There are some archives on the web that will publish manuscripts that haven't been technically peer reviewed or even picked up by a journal. And I find them a little bit problematic. They might be useful for some projects, but for most of what we are working on, I would probably steer clear of them, but I can make them available later.
Right. So we have a question. Can we contact you, Jim?
Yes.
Straightforward, yes.
I should have said that at the beginning. Look, yeah, send me an email. My contact is on the guide, and Eddie's got my contact as well. Again, I don't know what we're working on. I would prefer to use, say, Medline or the other databases if we need to produce some kind of structured search for our capstone project, for example. But what I will quickly demonstrate shortly is an excellent resource such as Web of Science or Scopus, which, to be honest, I would rather use than the library's discovery service, which I find frustrating. I've built a rather structured search now, but what I will quickly demonstrate is the same search, but on Web of Science and maybe Sonal as well, because there are some differences, slight differences in the way these databases work.
Right. So before that, could you take one more question?
Yeah, sure, please. Yep.
What if you want to do the literature search for the topic in a specific setting? That is country or region. How will you specify that in the search?
You can always just add the country to the search. It can be a little bit complicated depending on the jurisdiction. For example, if I'm looking at Australia, I will always include, say, Australia, and I'll truncate to pick up Australian. Then I would always do or each state jurisdiction, or Queensland, or New South Wales, or Victoria, or Tasmania, etc. Australia will pick up Western Australia and South Australia. For federated jurisdictions like Australia and the United States, it can be frustrating, but, you know, Australia or the States, that can be difficult with the United States. But I would always keep in mind differences in phrasing. I would run, for example, United Kingdom or Great Britain. Burma or Myanmar. Russia, truncator will pick up the Russian Federation. So just think about the country itself and any differences in spelling. The Slovak Republic or Slovakia, again, just truncate the relevant part of the country name to pick up differences in spelling. Each country does actually have a mesh heading, so you can always go back to the mesh thesaurus and type in Korea, and it'll pick up, I don't know, maybe the Democratic Republic or South Korea or whatever. You can always refer to the mesh thesaurus for country names, but just keep in mind differences: England or Great Britain or United Kingdom, for example. But yes, specify country or group of countries if it's relevant. Add them as a group. We often look at, say, for example, middle income or developing countries. We can even build a whole country group and just put the or between them to capture those different jurisdictions. That's good practice.
Right.
Yep.
Eliane, would you like to ask your question, or you want me to read it out?
Could you hear me?
Yeah, yes, I can hear.
Good.
Oh, hi, I'm Eden. Thank you for this section. I would like to know because I'm gonna looking at the policy field about diabetes control, and I would like to use an advanced search in the platform, which is called APO platform. That is Analysis Policies Observatory platform, which have many resources from government and the organization to analyze the policy about an issue. So I have a look at this platform, but I didn't find any advanced search function in that. So in terms of that, how can I do the like a systematic search literature at that platform?
Look, depending on the actual platform, a lot of the platforms don't necessarily have great search options. A lot of, for example, trials databases don't have them. Most of the mainstream databases, I'm thinking about the EBSCO products, Web of Science, the Elsevier products, the Ovid products will have an advanced search option. My preference is to select advanced search. Look, it's hard to say. I'll run a Web of Science search shortly. If there is an advanced search and it looks user-friendly, select. Tools such as Scopus and Web of Science, I would rather just use the regular default basic search for those products because they're nice and easy. It totally depends on the product. Again, we can't look at every database now, but I can take the question on notice, and we can look at that resource later if you like. Okay. But it is often difficult to translate a search from, say, Web of Science to another product. A lot of the more independent or smaller products don't often have user-friendly interfaces, but most of the resources that we're looking at should at least have some pretty good platforms. So look, if there's a particular database that's not working for you or you need help with, we can take that on notice, and we can catch up later and look at that. But the point I'm making is it's not always possible to translate a search from, say, Web of Science or Medline Ovid to another database. Mm-hmm. It's not always possible.
Okay, thank you.
We will come back to questions later, but what I want to quickly look at now, before we run out of time. Okay. Stop my video again. Web of Science and Scopus. These are excellent resources, even if we aren't doing a formal thesis or structured search. I think they're excellent resources. And look, my rule of selecting advanced search, I'm about to break that because I think tools such as Web of Science and Scopus, these two specifically, I would always opt for the basic search and only use the advanced search if necessary. I like the basic search, the way it's set out with Web of Science and Scopus. It's much more user-friendly than most other databases. I want to quickly talk about some important search syntax here. Look, here's my search that I built on Ovid. In fact, what I'm going to do, I'm going to go back to my Word document because this will be easier to demonstrate. Right. Keep this in mind. Ovid databases, can you see the Word doc? I hope I've gone back to the right page here. Words adjacent to one another on Ovid databases, such as eating disturbance, eating disorder, will be automatically processed as a phrase. Eating disorder, together, eating disturbance together, young adult together, as an automatic phrase. Ovid is unique. Google Scholar, Web of Science, Scopus, the EBSCO databases. For multi-word phrases, enclose them in speech quotes. Young adult. The space between words on most databases, including Google, will be processed automatically as an implied and, eating and disorder, or eating and disturbance, or anorexia. So where there is a multi-word phrase, other than Ovid, lock them in speech quotes. That's important. So here we're back on Web of Science. There's my first search. What I like about the platform, nice and flexible. Look at that, add row. Here's my second search. Add row. Search 1, search 2, search 3. There's the and built into the platform, search. I get 223 results on Web of Science. We are searching the title field, the abstract field, and the keywords field. So even my point, I suppose, is this: if I'm working on a regular report or assessment task, I like to run my searches on Web of Science or Scopus to begin with. And for our subject area, I've made this point previously, our subject area in population health, global health, we are often looking for literature that's not in your conventional health or medical fields. These databases are comprehensive, they're multidisciplinary, they're searching a variety of discipline areas: sociology, gender studies, development, economics, public policy, etc. So they're good resources for population health, global health topics, Web of Science and Scopus. So by all means use them. Easy to use. Find the full text if there's no full text at the database level. Easy to export as well from them. So what I would like to do with my searching is I can build a search, the search that I'm using now on Web of Science with the quotation marks around multi-word phrases. I can copy and paste this exact search into Sonal or into Scopus. I can reuse that search across these different platforms. It's the same as the Ovid search, but again, I've put speech quotes, quotation marks around the multi-word phrases. Nice and easy. The advanced search is there with Web of Science, but look, I rarely use it. I only use it if I'm really building a long structured search. I think the nice platform setup is good. How many databases do you search? I should have answered this earlier. Look, again, if we're working on a scoping review or some kind of systematic review, I would typically look at maybe 2 or 3 specialist databases. I would also look at a generalist database depending on the topic, such as Web of Science or Scopus. I think, you know, 3 to 4 databases is pretty comprehensive, certainly for, say, a capstone project. For your regular, you know, continuous assessment tasks, an essay or a report or whatever, look, maybe just 1 or 2 searches, one of, say, Scopus or Web of Science should be sufficient, I think, for those sorts of assessment tasks.
Jim?
Yep.
So there's a question here, while you're still on that page, on Web of Science.
Mm-hmm.
I decided to cut you because I thought this was important. Any guidelines on using the not function or the not term that will not make the search too limiting? I do have this question also. Yeah,
I get this question frequently, and it's a good question. Look, I rarely use the not operator these days. It's a little bit blunt. Look, for some topics, especially if we aren't looking at, say, animal subjects, I'm thinking here of more of the medical topics. We don't want, you know, guinea pigs or rats, for example, so we can not animals to just limit to humans. I find it dangerous. For example, last week I was working with a student on, now what was the topic? It was child sexual abuse. She said, how do I, but actually the scenario was this, for example, we wanted papers on child negligence. Most of the results we were getting were child sexual abuse. So when we ran child abuse, not sexual, we ended up missing a lot of papers dealing with child negligence or child neglect. That's because so many topics are addressing several different areas. So there was a paper looking at child abuse generally, which was looking at neglect as well as sexual abuse. So when we applied the not operator, hoping to remove the papers looking at child sexual abuse, we ended up removing half of the papers looking at child neglect as well, because the paper was looking at both forms of abuse. I have used the not operator occasionally effectively, but I try to avoid it because I find it uncompromising. I would prefer to come up with a good number of results, and at the filtering stage, the screening stage, when we're looking through title and abstract, I like to filter manually and then exclude studies that might not be relevant. The not is there to use, but it can be quite dangerous, especially with systematic or scoping reviews. With platforms such as Ovid, you'll have to do a command search by actually writing not. We won't look at that now, but there are instructions available. I don't use it often because, again, it can be quite dangerous if you're searching. You can exclude too much stuff.
Jim?
Relevant stuff. Yep.
So one last question, if there is no other question. One last question.
Mm-hmm.
I know librarians do not like this, but students use it anyway. Google Scholar.
Look, I use Google Scholar myself. It's a good resource for some additional background or supplementary searching, and I always say this: use it, as an additional search tool. Again, it totally depends on why we are searching. For structured or systematic searching, it's difficult because you can't reproduce a search. Google doesn't support truncation or proximity operators, which we haven't looked at here. That's a more sophisticated version of the AND, where we can group terms together. I would not use it for systematic review searching because it's difficult to reproduce the search strategy. The Google algorithm also is pretty chaotic. I can run a search on Google Scholar on my home computer and rerun the search on my work computer and get different results. I use Google Scholar, especially for grey literature. All Google Scholar is doing is sourcing, again, the data from the open web, especially publishers' pages and university repositories, etc. But it's extremely difficult to reproduce a search and get the same results. But that said, by all means, as a quick search when you're researching a topic, use it. It's discouraged in systematic searching because, again, it's difficult to reproduce the search. It's just too chaotic, too random. Yep.
Right.
Yep.
So thank you very much for your time.
It's good.
It's been an interesting seminar, and it's been short and straight to the point. I think we have some more questions.
Sure. Yep.
One more question. Oh, just I think a comment that search engine optimization makes results unreliable and dependent on third-party influences, I would imagine.
What was that? Sorry, Eddie, I missed that. Search engine
optimization. So I think I do understand this. It's this thing websites do to be able to bring their publications or their content to the top of Google searches.
Look, look, with grey literature searching, I don't want to be down on Google or the regular search engines. Look, they do support domain searching. So, for example, and I encourage this with grey literature. We can use, for example, the site code site.gov.au to limit our results to, say, the Australian government jurisdictions. If we're looking for some government reports produced by a state health department, for example, the Google can be very useful. The other day I was searching WHO reports, World Health Organization, site who.int to limit my results to the World Health Organization domain. Then I can type in some terms to focus on those results. But yeah, you're certainly right. The algorithmic or optimization programming does frustrate searching on Google. Again, it depends on the sort of literature that we're looking for. I use regular Google to find grey literature, especially, again, professional or government reports, because I hate to say it, they're not going to be available on Web of Science or Medline. A lot of the grey literature is only going to be available through the open web. Yep. Again, one of the issues with Scholar is it's not necessarily scholarly, and we don't know exactly what's on Scholar. Scholar is basically just harvesting, again, citation data, mostly from academic publishers, from some open source repositories, university repositories, etc. I mean, it's just a large sweeping tool. It's good for just some supplementary searches, but it's difficult to control a search and to reproduce a search with Scholar. I can build a precise search using field codes on Medline Ovid, and I can send that to a colleague, interstate, and again, she can rerun that search and get exactly the same results. That's important for systematic reviews and scoping reviews. It's impossible to do this sort of a structured or systematic searching with Scholar. It's not designed for these tasks.